Good morning, everyone. Let's see, schedule here. Today's Monday, February 6th. So today we will talk about session 1.6. And then this Friday, you will have homework 3 and the first quiz. So your quiz will have like 2 to 3 questions, and you do it in Blackboard. So you have a whole day to start your quiz. Once you start it, then you have to submit your quiz within 30 minutes. So my recommendation is use your laptop to open the quiz. And then when you see the quiz questions, write down your answer on a piece of paper. Take picture of the paper and then combine into a PDF, email to yourself, and then use your laptop to download that PDF and upload it to Blackboard. Okay, Eric? Yes?
So we're uploading the Blackboard PDF of our answers that we wrote down.
Yes. Right. So you don't have to print out the quiz 10 times. So just write down your answer. But if the quiz has 2 problems, so label it question 1, question 2. Okay? And sometimes maybe because the internet issue, if you accidentally log out and then you lose your first attempt. So I have changed the setting to unlimited attempts. So you can open a second attempt to do it, upload it right away. But you have to email me and say why you did the second attempt. Okay, everybody? Mm-hmm. All right. And last Friday, several of you missed classes. If you missed classes on Friday, please make sure you watch the recordings to catch up. Okay, so you can go to TED Collaborate and click the menu button, recordings. Then you can see our last Friday's recording. Okay? All right, so today we talk about session 1.6. Other types of equations. So yes, this session is about solving equations. And we have seen some examples about solving equations, like a quadratic equation. Remember last class on Friday, we talked about 2 methods to solve quadratic equations. One is by factoring, the other one is by the quadratic formula. Do you remember the quadratic formula? Negative c plus or minus square root of c squared minus 4ac over 2a. Right, everybody? Make sure you can memorize it. All right. Okay. Now let's solve more types of equations. So the first one, polynomial equations. This is the easiest one. Okay, when solving a polynomial equation of degree greater than 2. So first step, we write it so that all terms are on one side of the equation and 0 is on the other side. So we move all terms to the left-hand side. Okay, everybody? Last class, we remember we said A times B equals to 0. So if you have a product of 2 factors equals to 0, even only if one of them is 0. Alright, everybody? But if you have a product of 2 factors equals 1, does that tell us anything? No. A is not 1, B is not 1. We don't know. Okay? So this rule is only true when the right-hand side is 0. That's so important why we want to move all the terms to the left. So the right-hand side is 0. Then we can pass it to the left-hand side. Yeah. Okay, so look at the first one. Move all the terms to the left-hand side. So we subtract 2x. Right, everybody? Mm-hmm. Then we have x cubed minus x squared minus 2x equals 0. Move all terms to the left-hand side. Can we factor it? Yeah, what's the common factor? X. Okay. Hey, how about you guys take turns to answer my questions? Hey, Derica. After we factor out the x, what's left? Mm-hmm. Mm-hmm. Yeah, very good. All right. So we have a linear factor. This is a quadratic factor. And then we ask, can we factor this further? If you can factor it, that's good. If you don't know how to factor it, it's okay. You can use quadratic formula on this quadratic factor. Is that clear, everybody? Hi! Do you know how to factor it? Okay, so x squared. What are the factors of x squared? X and x, right? X and x. Then you look at the constant term, which is -2. What are the factors of -2? -2 and 1. Yeah, -2 and 1. Okay, and then we check. Multiply by the outside, the outer terms. We get x times 1 is x. Multiply the inner terms. -2 times x is -2x. Now, you add them up. Do you see we get -x? So this is the factoring. Okay, everybody? This example is easy. Okay, so I suggest you to do more harder examples. So we call that, if you want more exercise on factoring, go to Blackboard. Click the Mobius resources and then Mobius lessons class page. Okay, and then let's see. Chapter 1, prerequisites. Section 1.5, factoring. Okay, so it talks about how to factor trinomial with leading coefficient 1, how to factor by grouping, how to factor perfect trinomial, perfect square, and the difference of squares. So factor by grouping, then you can see here are the extra exercises. Okay, so write down the answer, and then you can click how did I do, then you know whether you're doing right or wrong right away. And then you click try another one, it will generate a new problem for you. Okay, everybody, factoring is so important in this course. You need it all the time. Okay. Yes. Okay. So, and usually the example we do in class is some of them are like easier, and then your homework problem will be harder, exam problem will be harder. So do more practice. Okay, everybody. So therefore, we get a factor. So we set each factor equals 0. So x minus 2 equals 0, x plus 1 equals 0. And we put OR, right? And then we solve for x. So we get, this is x is 0. This x is what? Positive 2. And this one? -1, yes. So here we have 3 solutions. And what's the degree of this polynomial? What's the degree? The highest power? 3. So it's degree 3 polynomial equation. It should have 3 roots, 3 solutions. Okay, everybody? A quadratic equation usually have a solution, 2 real solutions. It depends on the discriminant. You might have 1 real solution or no real solution. In that case, you will have 2 complex solutions. Okay, everybody? All right. That is example 1. Example 2. Okay. So the first step, move all the terms to one-hand side. And then try to factor. Do we have a common factor? Yes, factor it. All right. Thank you. Okay, now look at this problem. All terms are on the left, right, everybody? Do we have common factor for all the terms? No. Okay. So we have, yes, have those two steps. Now, if you have three terms, okay, try the factoring like this. But if you have four terms, try grouping. Okay, so group the first two together, group the last two together, and try to factor. Okay, so if we see four terms, group them into pairs. So here we're grouping the first two terms together and the last two terms together, right? And then, oops, we factor it. Okay, let's do the, what is the common factor of the first two terms? X squared. Yes, we factor out x squared. What's left? Thank you. Let's do that. What's the common factor of the last two terms? Yes. What's left? Yes. Oh, everybody, do you see we have the common factor x minus 3? Mm-hmm. So next student, we factor out x minus 3. What's left? Yes. Okay, good. Now we got a linear factor and a quadratic factor. Questions. If you see a squared plus b squared, can you factor? No. If you see a squared minus b squared, can you factor? 5, and you get, what's a squared minus b squared? A plus b, a minus b. Okay, all those formulas, write it down on a piece of paper and then tape it on your restroom door so you see everything. Okay, so therefore we get x minus 3 is 0, or x squared plus 3 is 0. What's x? 3. And then this one, because x squared is always greater or equal to 0. So your left hand side is always greater or equal to 3. So it won't be 0. Therefore, this one is impossible. So we don't look at it. Is that okay, everybody? Mm-hmm. So here we only have one solution. All right. Okay, so that is example 2. All right. And that is how we solve polynomial equations, right? Move all the terms to the left-hand side. So the right-hand side is 0. And then factor. Okay. All right, how about equations involving rational expressions? Okay. So, okay, in this case, for rational expressions, the order of this will be different. Okay, my suggestions. First one, find the least common denominator. That's the first one. Because you want to find the domain. Remember, domain is x value such that our expression makes sense and our denominator cannot be 0. Okay, do you remember that example we did in 1.3? We find the domain, x cannot be 2, x cannot be -2, and then we solve the polynomial as a fraction. We solve the equation and end up getting x was -2. But because it was outside of the domain, therefore we don't have any solution for that problem. You remember that? Mm-hmm. Yes. So here, first steps. Find the least common denominator and find the domain. Domain is, we set the denominator not equal to 0. Okay. And then we combine the rational expression into one big fractions. So I would say like, so all the two terms has a least common denominator. And then we can multiply the LCD. So I would say step 3, multiply the LCD to clear all the denominators. Okay, and then we get a polynomial equation. So then 4 steps, yeah, the 4 steps, move all terms to the left hand side and factor. Okay, because these 2 steps is just like the step of polynomial equation, right? And then finally, make sure you check your answers. Is your answers in a domain? Okay, if it's not in a domain, then we don't have any solution. Is that clear, everybody? So 1, 2, 3, 4, 5, 6. 6 steps. Okay, let's look at this problem. First of all, let's figure out what is the least common denominator. Okay, can we factor all of them? So look at the first denominator. Can we factor them? What's the common factor? Okay, who's next to this? Is it Jason? Okay. What's the common factor? X squared and 3x. What's the common factor? X. Right? You see, we have x times x. And then here we have 3 times x. So the common factor is x. So we factor out the x. What's left? Huh? What's left? Yeah, very good. Okay, look at the second term. Let's do that. How can we factor x squared minus 9? Factor it. What's something? X squared minus 9. 9 is what squared? 3 squared. Okay, write down the formula. I know you forgot that. And again, so if you see a squared plus b squared, can you factor it? No, we can't factor. But when you see a squared minus b squared, what do you get? Yeah, a plus b, a minus b. So now, what is x squared minus 9? Yes. Right, anybody? So this one is very, very important. Write down on your piece of paper and then review it every day. Okay, and then the last term we have x plus 3 is the denominator. So our least common denominator will be, you collect all the factors in the denominator. The first one, you see, we have the x, right? And we have x minus 3. So x and x minus 3. And then look at the second term. Oh, we have x plus 3, right? So we write out x plus 3. Do you write out x minus 3 again? No, we already have x minus 3. Right, everybody? That's why least, the smallest common denominator. X plus 3. See, we already have x plus 3. So this is the least common denominator. And we say what? It cannot be 0. Yeah? So all the factors cannot be 0. X cannot be 0. X minus 3 cannot be 0. X plus 3 cannot be 0. So x cannot be what? And x cannot be -3. Right? That is the first step. We find the LCD and the domain. Okay, everybody? And then next step, so we want to get all the common denominator. Look at the first term. Okay, let's look at the first term. The first term we have 1 over, let's use the factor form. Okay, what do we want to multiply so that we get the least common denominator? X plus 3, right? And then minus 2 over, put the factor form, x plus 3, x minus 3. What do we want to multiply? X. Is everybody okay? Right? Yeah, this is our goal, least common denominator. So we meet the x, then we multiply by the x on both numerator and the denominator. Okay, and then the right hand side equals 1 over x plus 3. Okay, what do we multiply? X and x minus 3. Right, everybody? Okay, now we make sure all the terms have the least common denominator. So we can multiply by the least common denominator to get rid of all the denominators. Right, everybody? So, yeah, so check. See, step 2, we combine them. We get this. And step 3, multiply by the least common denominator to get rid of all the denominators. Then it just feels like, oh, you just erase all the denominator. Then what do we get? We get 1 times x plus 3, which is x plus 3, minus 2 times x. Right, everybody? X plus 3 minus 2 times x equals x times x minus 3. Right, anybody? We get rid of the denominators. Okay. Now we get a polynomial equations. Let's solve it. Okay. Combine the like terms. What is x minus 2x? Let's do the, what is x minus 2x? Yes. Negative x plus 3, right? Can you also tell me what's the right hand side when we distribute it?
X squared minus 2x.
Yes. Right, everybody? Okay. So this is a quadratic equation, right? Let's move all the terms to one hand side. So do you prefer to move the terms to the left or move the terms to the right? Do we move all the terms to the left or move all the terms to the right? Right. Yes. Because x squared, so you see x squared is right here, and its coefficient is positive. So we hope to have the leading coefficient is positive. Okay? So it's more convenient for the next level of factoring. Then how do we move this negative x to the other side? We both sides add the x, right? So we add the x. How do we move the 3? Both sides, what do we do? Subtract 3. Is that okay? I'm doing 2 things on one step. Is that okay, everybody? Then these cancel, this cancel. We get 0 equals. Okay, next student. 0 equals how many x now? Negative 2x. And the constant term is negative 3. Right, everybody? Oh, this is a quadratic equation. Now, can we factor it? Next student, how can you factor it? What are factors of x squared? X and x, right? What are factors of -3? -3 and 1. Yeah, very good. Yes, everybody? Mm-hmm. Yes. This problem is also easy. Okay. And then we set each factor equals 0. Okay, put or. And then what is x? Next student. What is x? So we solve for x. What do we get? 3. And this one? -1. Okay. Then we check the domain. Okay. So when you have equations involving rational expressions, this domain is not all real numbers. You have to check the domain in the last. Okay. Then x equal to 3? No. See? Check the domain. So check with the domain. X cannot be 3. So our final answer is x equals -1. That's the final answer. Everybody clear about those 6 steps? So when you do your homework, follow the steps. Okay. All right. So next one. How about solving equations involving radical expressions? So that means you have a square root. Do you still remember what square root look like? Have you seen square root before? Yes. Radical? Yes, square root. Do you know the things inside the square root cannot be negative, right? Otherwise, you have complex numbers. You don't have real numbers. Do you know complex number that I equals square root of -1? No? Okay. So complex numbers. Okay, so we define square root of -1 to be I. So therefore, if you get something like square root of -25, then you consider this as 25 times -1. Then because if you have multiplication, you can distribute the power. The power of square root is like 1/2, right everybody? So this is square root of 25 times square root of -1. What's square root of 25? 5. The square root of -1 is I. So this is a complex number. So if the thing inside the square root is less than 0, then we don't have any real solution. Okay, we get complex solutions. But when we are solving equations, for now, we want to find real solutions. That's why we require the domain of the possible x values. We need the x to we need the thing inside the square root to be greater than 0. Okay. So let's look at the steps. Step 1, try to rewrite so that the different radical terms are on the opposite sides. And square both sides. So I would say step 1, isolate one square root term. Okay, isolate means on one side, we only have one square root term. Okay, all the other terms is on the other side. Okay. And then square both sides, step 2. Okay, we may need to repeat this process. So repeat step 1 and step 2 to get rid of all the radical. And then we will get a polynomial equation, so solve it, and finally, gotta check our work. Okay? So let's see. First step, isolate one square root term. So here we have two square root term on the left hand side. You want to isolate one of them. So maybe let's move the second term to the other side. Okay, so we only have one square root term on the left side. So we add square root of x plus 4 on both sides. We get square root of x plus 4 equals 2 plus square root of x minus 4. That is step one. See, on one hand side, I only have one square root term. Is that okay, everybody? Yes? Now, square both sides. Do you see when we square both sides? This square root will be cancelled, right? So this step one, we isolate one square root term. Step two, square both sides. Okay, and on the left, square and square root cancel. We have x plus 4. Right? How about on the right hand side? This is a complete square. Now, we call it formula again. What is a plus b squared? A plus b times a plus b, right? So it's a squared plus ab and ba. So that will give us 2ab in the middle. Right, everybody? When you distribute it, you get a times a is a squared plus a times b. And then plus b times a. ab and ba are the same thing. That's why you get 2 copies of ab plus b squared. Okay, everybody? So be familiar with this formula. Now, a is like 2, right? B is like the square root of x minus 4. So, again, a squared. So we have 4. Right? Or let's do it slowly. This is like a, this is like b, right? So a squared is 2 squared. And then plus 2ab. 2a is 2, b is the square root of x minus 4, plus b is square root of x minus 4 squared. Okay, by the way, if you get a minus b squared, the middle term will be okay, everybody? Everybody okay with this step? Yeah, 2 squared is 4. Get rid of yeah, exactly. So the next step, this will be x minus 4. Yes, and this will be 4. Yeah, good. So we continue. So x plus 4. I'm just writing down like all the details. Okay, so now you can see 2 squared is 4. And 2 times 2 is 4. Now square root and square cancel. We have x minus 4. Right? Is that your question? What was your question? Which step? Here? So,
I don't understand why you didn't just put this here and this here, so this would cancel out.
no, it's not. So that's why we use this formula. We said very important. A plus b squared is not equal to a squared plus b squared. If you have a sum, you cannot distribute the power. If you have a product like a times b, yeah, you can distribute the power. You get a squared times b squared. Or if you have a over b, you can distribute the power. But if you have a sum, you cannot just distribute the power. Remember we said a plus b cannot be factored.
Oh, it's adding inside. Okay.
Yeah, it's adding inside. When you have addition or subtraction, it's not simply just put the power, move the power inside. No, you see, it's actually we have the middle term, the 2ab. Okay, everybody? I know many of you are still not familiar with the formula. Please, do you promise me when you get home today, you can have a piece of paper, write out all those algebra formulas, and then tape it on your restroom door. So when you go to the restroom every day, you can review it. This formula, very, very, that's the effective calculation. If you're not familiar with the formula, you may make a mistake.
No, there's no summing and adding any numbers to
Yeah, then we can move the square.
we just have like four.
Yeah, 4 times x nine. Yes, yes, right, yes. Very good. Okay, now, oh, do you see on the right hand side? 4 and 4 cancel. Right, everybody? And now, what we need to do is we need to isolate the square root term again. Right, everybody? We're going to isolate this. So, oh, can you see we have an x here? We want to get rid of the x, so we both sides subtract x. Right? Both sides subtract x. Okay. Isolate means you only want to have that square root term on one side by itself. All the other terms, get rid of them. We can move to the other side. So we subtract x, subtract x. Oh, the good thing is this cancel and this cancel. We get 4 equals 4 square root of x minus 4. Right, everybody? If you can simplify it. Simplify. Do you see the common factor 4? Yeah, let's simplify. We want to work with smaller numbers. Right? You don't want to work with crazy big numbers. It's bigger chance to make mistake and it take more time, right? So here we have common factor 4 divided by it. So we get 1 equals square root of x minus 4. See? We repeat the process. We isolate the square root term. Then we can square both sides again. What is 1 square? 1. Right? So, okay, let me write it down slowly. 1 square and square root of x minus 4 squared. Yeah, exactly. So that's 1 equals x minus 4. What's x? What is x? 5, exactly. Yeah, we add 4 on both sides. We get x equals 5. Okay? Are we done? Now make sure you check. So by checking, that means we need to plug into the original expression and see if it works. So check. You see, we get square root of x plus 4. Now we plug in x is 5. We get 5 plus 4. What's that? Square root of 5 plus 4 is 9. Square root of 9, 3. Okay, that's the first square root term in the equation, right? So you have to plug in all the square root term and see if it makes sense. If for one of the term you plug in, you get square root of a negative number, then you automatically stop and say no solution, no real solution. Okay, everybody? So yes, that's the first square root term. Let's plug in the second square root term. So x is 5. What's 5 minus 4? 1. Ooh, square root of 1 is 1. See? That equation means 3 minus 1. Is it equal to 2? Yeah. So check. This is a solution. Okay? So here are the steps. Isolate one square root term and square both sides to get rid of that. If you still have more square root terms, repeat this process. Questions? Add the 2 to the 1. 2 plus here. This one? Yeah, 2 plus that.
So if you make it, it'll be 1 plus 2.
1 plus 2. You mean plug in here? You mean plug in x equals to 5 into this equation? To this one?
Yes.
Yeah, then you will have 1. Oh, you got 3. This is 3. 3 equals 2 plus 1. Yeah, so yes, that's true. Right. Because all of these are equivalent. Yes, we can add both sides by number, subtract both sides by number, multiply by or divided by times 0. All of these are equivalent. Yeah. Okay, so everybody clear how do we solve equation involving square roots? Okay. Let me also write it down. When you see square root of a number, okay, square root of a number, then we need that number to be greater or equal to 0. Okay. All right. Now keep going. Let's see. Okay, so this is an example. We might not have time to go over all different types of examples. So I will let you to do this one at home. Okay, everybody? I will let you to do this one at home. So promise me you will do it. Promise? Promise? You need a lot of practice. Okay, now let's do example 6 now. All right. So first step, we want to isolate one square root term. Right, everybody? So let's move this guy to the right. So we add both sides. Add 2 square root of x minus 2. Then we have square root of 2x plus 3. And the right hand side we have 2 square root of x minus 2 plus 1. Is everybody okay with that? Okay, so we isolate one square root term. What's the next step? We square both sides. So we have square root 2x plus 3 square is 2 square root of x minus 2 plus 1 square. Right, everybody? Okay, what's the left hand side? The square root cancel. We get 2x plus 3. But now can you tell me what is the right hand side? 2 times the square root of x minus 2 square. Okay, tell me again. What is a plus b squared? A squared plus 2ab plus b squared. So here, the a is like what? The a is like 2 times square root of x minus 2, right, everybody? This is like the a. Yes? So a squared, and then what? Plus 2a, right? A is square root 2 times square root of x minus 2 times b. What's your b? 1 plus b squared, which is 1 squared. Right, everybody? Okay. We're using the complete square formula. So 2x plus 3. Okay. Here, what is 2 squared? 4. Right, everybody? And then, do you see we get square root of x minus 2 squared? Then they cancel. We get x minus 2. Is everybody okay with that? Yeah, because now it's multiplication. Multiplication, we can distribute the power, right? We get 2 squared is 4. And then the square root of x minus 2 squared, the square root and square cancel. We get x minus 2. Right, everybody? Okay, 2 times 2 is what? Just 4. And then 1 square is 1, right? Okay, now let's simplify it. Our goal is to isolate the square root term, which means you're going to distribute it and then you're going to move all the other terms to the left hand side. Is everybody clear what we are doing? Mm-hmm. Okay, what we distribute? What do we get? Yeah, very good. And then we have plus 1, right? So let's move the plus 1 together with the minus 8. What's minus 8 plus 1? Minus 7, exactly. Okay. How do we move this 4x? Both sides. What do? Both sides. Add 7 and subtract 4x. So subtract 4x, add 7, add 7. Look at your left. 2x minus 4x is negative 2x. 3 plus 7, 10. That equals 4 square root of x minus 2. Okay, everybody? Alright, so here, if you can simplify it. You see all the terms has a factor of 2. So let's divide it 12 sides by 2. Do you want to work with small numbers or big numbers? Small numbers. So if you can simplify it, simplify it. If 12 sides divided by 2, what do we get? Negative x plus 5 equals 2 square root of x minus 2. Right, everybody? Now we're ready. Once you isolate it, you square both sides. Okay. So square both sides. Minus x plus 5 squared equals 2 square root of x minus 2 squared. You might have questions. Why don't we divide it by 4? But then if you divide it by 4, you get 5 halves. Do you want to work with fractions? No. That's why keep the 2 there. Alright. Negative x plus 5 squared. What is that? X squared minus 2 times 5 is 10x plus 5 squared, 25. Is everybody okay with this complete square? Yes? Mm-hmm. On the right hand side, 2 squared, 4. And then square root and square cancel. Right, everybody? Yes, 4 and square root and square cancel. Okay, so we have x squared minus 10x plus 25. Distribute 4x minus 8. Right, everybody? Move all terms to the one hand side. See, we have a quadratic equations. So we subtract 4x. And then what? Add the 8. How many x? 14. What's the constant term? 33. Good job. Can we factor them? What factors of 33? 11 and 3, plus or minus? You get -4. So plus or minus? Negatives for both. Right, everybody? Then you get -11x and -3x, so -14x when we add them. Okay, x minus 11 is 0, or x minus 3 is 0. So x equals 11, or x equals 3. But don't forget you need to check. Okay, let's check. 11. When you plug in 11, you get what? Square root of 2x. X is 11 plus 3. This is okay. Right? You don't have to calculate what that is. You know this is positive, so it's okay. And then the second expression, 11 minus 2, is also okay. Right, everybody? And then check the 3. 2 times 3 plus 3 is okay. And then 3 minus 2 is also okay. So both of them are solutions. Oh, sorry. With is not enough. We actually need to check plug in, okay? So, sorry. Missed it here. How about let's continue on Wednesday, okay? So, this is kind of wrong. And we'll explain why on Wednesday. Bye.